In stats, we introduced box plots. So all that we're doing is off of this problem right here in this data set. So this is a little different than the printed handout. In the printed handout, you see stuff about North Carolina. But we decided to just look, or I decided, sorry, to go off of these paper airplane distances. So there they are, if you want to use that and try and duplicate what we get. If you didn't see the last video, you need to know how to type it into a calculator. So first off, I would press Control Up and close all these documents. Start from scratch. And you need to name the list. I always name it A, and go from there. So for example, if we're looking at this data set right here, you need to type those numbers in. I can't remember what they are. I'm just going to make some numbers up. So you need to type in the numbers, not those numbers. Those aren't right. And you press Menu, Stats, Stat Calc, 1var Stats. One more time. Let me press Escape. Menu, Stats, Stat Calc, 1var Stats. We have one list. I named my list A, and that's all you change. You can press this tab button, see it in red over there, and you can move pretty quickly through this screen and hit OK. And you get all your results. These are not the correct results. I made up those numbers. All right. You can also make a graph if you go Home and you click the bars to the right of the spreadsheet. You click on the horizontal axis. You got to use the touchpad for that. And click the name you gave it, and you get a nice dot plot. If you go to Menu, Plot Type, you can see box plot. And there it is. Kind of a weird box plot because I only picked like, what, 6 or 7 numbers, so this is kind of weird. But anyways, I'm going to do it all by hand up here. So we were on, I believe, this page of the notes. And we need to talk about how the center is affected by outliers. So first off, if we have a nice symmetric distribution, let's draw a bell curve. That one came out okay. Then it's symmetric. The median is dead center. And no outliers are pulling the mean. This thing is equivalent above and below. So the mean is roughly the same as the median. So you know that the mean is approximately equal to the median in a symmetric distribution. If you have a right skewed distribution, that changes. So remember, it's all piled up on the left and it tails to the right. Tail is on the right, that's why it's right skewed. I would guess the median is probably around here. It's hard to know for sure. But it's still the middle point. Not necessarily dead center because there's more values on the left. I hope that makes sense. But it is the middle point. It's the true middle. And the mean will be greater. You know that for certain. Because those outliers on the upper end out here, they're affecting the mean. And so in this scenario, we know the mean is larger than the median. And that goes in the opposite with left skewed. I know the median is probably around here. And those lower values are affecting the mean. So they're pulling the mean smaller than the median. And you know that for sure. The mean is less than the median. So I don't know if it's typed on here, but I can tell you the mean is affected by outliers. The median is not. Now, some people like to get kind of argumentative, and they start saying, well, what if one large number became a really small number? Then it would change the middle value. That's not what this is talking about. This is talking about whether or not a value is an outlier, like way far away from the middle, or closer to the center, not far from the middle. So it's not necessarily saying it will not change the median, but whether a large number is an outlier or not, that does have an effect on the mean, but no effect on the median. All right. IQR, that's another measure of spread. So when we go down, you have range. We've talked about range. That's right there. That's max minus min. That one is affected by outliers. But the IQR, when we find it, we're going to do Q3 minus Q1, and it is not affected by outliers. So let's write a tiny bit about IQR and quartiles. First of all, quartile 1 is the median of the lower half of the data set. And Q3 is the median of the upper half of the data set. And they're kind of tricky to find, because if you have an odd number of values, that means you ignore the middle number, you ignore the median, and you find the median of the lower half. It's very weird. If you have an odd number of values, you ignore the middle value and find the median of the upper half for Q3. If you have an even number of values, then you literally chop it in half and you find the middle of the lower half and the middle of the upper half. So it's very weird to do by hand. It's a little tedious if they're not in order already. So it's very nice that the calculator can output it. One last thing, IQR is Q3 minus Q1. That means IQR is not affected by outliers. Think of it like this. Let's say we're looking at our maximum observation, the largest occurring value. The question of if it's an outlier or not has no bearing on the IQR or the median. It's the max, and it has no effect on it. Now, if you make some weird scenario where all of a sudden that largest number becomes a super small number, of course, then it's going to shift everything. But whether or not something's an outlier, if it's already the max, it doesn't have an effect, whereas it does have an effect on the mean. So for those paper airplanes, the range was pretty simple. That was 574 minus 13. So that means the range is, let's see, 571, so 561 inches. but I typically just use the actual min and max. I usually say 13 to 574. The IQR is going to be 277, or we did one var stats, and we got Q3 is 277, and we got Q1 is 138. So by the way, if you want to check these, rewind to the beginning where I displayed the data set. So type those into your calculator, and you should get Q3 is 277, Q1 is 138, which means we go 277 minus 138, and we get 139. By the way, just in case I didn't say it in the last video, Q1 is the 25th percentile of the data set. And Q3 is the 75th percentile. All right, we're almost done. So now we need to find if we have outliers in this paper airplane data set. So what you do is you come down here, and there's this formula, this agreed upon formula, where we find these lower and upper boundary lines. And you just need to be organized when you do it. So when you find that lower boundary line, whether or not something's a outlier on the lower side, you're going to take Q1, 138, minus 1.5 times the IQR. And you get negative 70.5, which means we have no lower outliers. You can just stop there, but you could say because no values are less than negative 70.5. For the upper boundary, we're going to take Q3, 277, and we're going to add 1.5 of the IQR, and we get 485.5. That means 574. And you want to skim through all of the data values. So if you look at all of them, only one value is greater than 485.5. Is an outlier, because there could be a couple, because it is greater than 485.5. You don't have to write the two because statements. You mainly just need to say whether there are outliers beyond or not. All right? And I believe we're going to make a box plot. So there are two types. One book that we used to use used these two names, skeletal versus modified. And skeletal does not show outliers. This means that they just want a quick and easy box plot. Don't bother with finding outliers. Modified shows them, and I promise you, I or College Board will ask you if they want you to do it. All right? This sentence is crucial. People mess it up all the time. Whiskers go to the largest and lowest non-outliers. All right, so let's do it real quick. So you make a number line. And I'm going to start at 10. No, I'll start at 0. 10 is kind of an odd number. We need to go to 574, so I'm going to go by 50. Let's see, 50, 100, 150. It was very weird just now. The video cut out and it all froze. So I'm hoping it's recording right now. It says it is. We will see. And 5 minutes went by. So I don't know. Hopefully it wasn't a lot of dead time. So back when we did 1var stats, we got all these numbers. And there's something that's really important that we have next to our box plot. So let me scroll backwards to it. It's at the very top up here. When you make a box plot, you have to have that 5-number summary. And you don't even have to label the 5 numbers. You can just write the 5 numbers with commas between them. All right, so those 5 numbers for first period were 13, 138, median was 198, 277, and 574. Make sure you title it. We're in first period, paper, airplane, distances, and you make a box. So we're going to make a box out of Q1 and Q3. So you make a line at 138, a vertical line at 138, and just do your best at guessing. So I'm going to say about right here. Draw a vertical line at 277. Once again, best guess. And make a box. Then make a line at the median, 198. It many times is not in the center. It's not unusual for it to be off center. I've seen the median drawn over here before. So don't worry about that. You just make a line where the median falls. And then you draw a whisker to the largest non-outlier. So if you look back at the lower and upper boundary lines, the lower boundary was way out here at -70. I usually draw a dotted line. You don't have to. And nothing's out there. So you draw a line to the smallest non-outlier, which is 13. You draw a line to the largest non-outlier. And first, let's draw the boundary line. So we got 485 for the upper boundary, which is probably around here. 574 fell beyond it. So that's about right here. You make a dot for it. And we need to know, I need to lower it. Let's get it in line with the box. There we go. That's a little better. We need to find the largest non-outlier. So I need to go back and look at the data set. Go back to the beginning. And you skim through there. I think there was a 400 number. 436. So we draw a line to 436. And you're done. right? That's a box plot showing outliers. All right, see y'all later. Bye.